Finally, Ibrahim Vazirabad is presenting the results of his project, and what he did was he improved the existing plugin interface between JSBML and CellDesigner, and also including a few sample plugins that can help to better support the SBML layout package.
Looking good? Okay, it works. I was a little worried. All right, hey everyone, welcome to my Google Summer of Code presentation entitled Improving the CellDesigner JSBML Plugin Interface. So I've been working on this project and with my mentors for around 4 months now, 4 or so months, and I'm really excited to be able to come to Combine to present the results of my work. So since my project lies at the interface of both JSBML and CellDesigner, I think it'd be beneficial to discuss both in a little bit of detail. So JSBML is a Java library that allows users to rewrite and manipulate SBML files. It offers full platform independence because it's entirely written in Java, and there's a plugin interface that links to the CellDesigner, which we'll be talking about in more detail later on in the presentation. So CellDesigner, it's a process diagram editor for biochemical networks. It's one of the most frequently used tools in systems biology due to its very powerful model layout capabilities. CellDesigner has the ability to access, not natively, but in the program, many SBML model databases, such as the biomodels database, and also the Panda database. And finally, a CellDesigner, its functions can be augmented by plugins, and this functionality is essential for this project. Oh, so one other aspect of this project, which I think warrants a mention, is the SBML layout and render extensions. So before level 3 of SBML was released, there was no way to, there was no standardized way, I should say, to specify how a biochemical network would be laid out, or how the network should be rendered, or how it should appear. But in 2006, the layout and render extensions were proposed, or packages were proposed as extensions to SBML. And just to reiterate, just to review, the layout extension deals with how model elements are positioned and what their size are, and the render extension goes along with the colors, sizes, line widths, etc. So CellDesigner has its own, own unique way to lay out biochemical networks and render them. So what we'd like to do in this project is connect both the SBML layout render extension with the CellDesigner specification. So CellDesigner and JSBML already have a plugin interface, so why should we improve it? Why is that at all important? Well, for 3 main reasons. For users of JSBML, having a bridge to CellDesigner will allow the users of JSBML to harness the powerful model layout capabilities of CellDesigner. For users of CellDesigner, on the other hand, having a link to JSBML will allow them to access the diverse suites of JSBML tools to work with SBML files. And finally, for the plugin developers, using this plugin interface along with the debugger can really ease plugin development. So really, all in all, we're looking to improve a good thing. In order to further develop the plugin interface, we found 2 areas in which improvements could be implemented. So first off, CellDesigner provides layout and rendering information that was not currently accessed by JSBML. So we wanted to import these attributes via the SBML layout and render extensions. Secondly, the model synchronization between JSBML and CellDesigner was incomplete. So JSBML was notifying CellDesigner of the changes in the core model structure, but the reverse wasn't true. When CellDesigner was, its model structure was being changed, pretty much JSBML wasn't currently listening. So when CellDesigner sends events, we need to update the JSBML model accordingly. So there's two-way synchronization. So as such, the project goal is to develop a small collection of CellDesigner plugins which will help us visualize the rendered layout additions from CellDesigner and visualize the two-way synchronization that we're trying to implement between CellDesigner and JSBML. So the first step in this project would be to map the CellDesigner plugin interface to the layout and render extensions. And the three plugin classes that we mapped were plugin compartment, plugin features alias, and plugin reaction. So we're going to look at each of those in turn for a little bit. Cool. So first, we have the mapping between the plugin compartment class and JSBML. So we can see over here, this is the plugin compartment class inside the plugin interface of CellDesigner, and it returns attributes that we want to map to the layout extension and the render extension. So we can see that attributes such as the height and width of the compartment, the x and y coordinates of the compartment, etc., these map with the layout extension, while the shape of the compartment and colors, line widths, etc., they map with the render extension. So let's move on to the plugin species alias mapping. This mapping is very similar to the compartment mapping we just saw, but with one caveat, one notable exception, and that the shape of the species can either be an ellipse, a rectangle, or a polygon. And the shape of the species is entirely dependent on the species type attribute. And the type of the species can be proteins, genes, RNA, drugs, etc. And finally, the plugin reaction mapping. So what I'd really like to focus on in this schematic is the position information attribute. And what we would be using this position information for is setting the position of the curve segments, which are in the layout class, and we'll be setting those in the reaction glyph and the species reference for the class. And also, one more thing I want to mention is that the reaction type determines how the curve is rendered, the reaction curve, how it's being rendered. Okay. So I've been talking a lot about plugin interfaces and plugins and plugin classes. So this really begs the question of how a user of JSBML can create a plugin in CellDesigner. So it's actually very easy. All you have to do, all a user of JSBML has to do is implement two abstract classes. One named abstract CellDesigner plugin, and the other one called abstract CellDesigner plugin action. And once those two classes are implemented, a link is formed between CellDesigner and JSBML. And as such, you can make any JSBML application into a CellDesigner plugin and take advantage of all of the abilities and attributes that CellDesigner has to offer. So let's talk now about the project progress in terms of plugins and our what we've accomplished. So first off, we imported the CellDesigner layout data into JSBML, and we're going to be able to visualize these layout additions via an SBML export plugin and a tree-based layout visualization plugin. Secondly, the synchronization between JSBML and CellDesigner has been completed, and we're going to be able to take a look at that synchronization process via another tree-based plugin. So let's go through each of those a little bit. So first, the first is file export plugin. So on the left, we see we have a CellDesigner model, and on the right, we have the CellDesigner plugin, the plugin written in JSBML. So I'm not so sure if we can see it. It's a little bit blurry, but we can see first. So this plugin prints out the SBML file. We can see that there's layered information inside of there. That's good. And up on the top, we can see there's a lock that says export SBML to file. When we click on it, we get a save dialog, which allows us to save this SBML file to a custom location. And this would be pretty helpful in later portions of working with the layout. So there are two other ways that we can visualize these layout additions. First, via a tree-based plugin, like so. And secondly, via an online SBML layout viewer written by Dr. Frank Bergman. So first, let's take a look at what the tree-based plugin can offer us in terms of visualization. So first, we can see that there are layout attributes that have been added to the layout extension that correlate first with the CellDesigner compartment, with the CellDesigner species, with the CellDesigner reactions, and all the textual information that the model contained. Okay, and then when we open up the export plugin and save our SBML file into a custom location and upload it to the online layout viewer, we get this as output. And we can see that the layout has been accurately translated from CellDesigner over to the layout extension JSBML. So layout that matches correctly. But just as a test, we also downloaded a model from the Panther database. It's pretty much a de novo nucleotide mouse synthesis pathway. Do the same thing, open up the export plugin, get the SBML file, upload it to Dr. Bergman's tool, and once again, we can see with very minor exceptions, the layout has been transferred properly. One more time, we downloaded the E. coli citric acid cycle for the biomodel database. Same thing again, get the SBML file, upload it up to Dr. Bergman's tool, and once again, we see that the layout is practically identical, which tells us that in a wide variety of cases, the layout information has been properly translated into JSBML. So, once the layout portion of the project was completed, we moved on to the second portion of the project, which was the CellDesigner and JSBML synchronization. So, CellDesigner plugin sent events or notifications when CellDesigner model element is added, changed, or deleted, or if when the current model is open, closed, or it's been selected. So to understand when these events are sent, we created a plugin that received and prints these events out. So here we have our plugin on the left, which is listening in on the CellDesigner model on the right. So we can already see that CellDesigner has sent events that the current model has been open and it's currently selected and ready for manipulation. So what happens when the user will move, let's say move one of the species, let's say he or she will move this one. We can see that once the user moves the species, 4 reactions send notification in addition to the species that they were changed in some way. And if the user decides to delete the species that they just moved, we get many different notifications. 2 reactions were changed, and 2 reactions were deleted in addition to the species that was actually deleted using that delete key. So we find that one user action can lead to multiple events sent by CellDesigner, and as such, we need to update the JSBML model accordingly. So once the CellDesigner events were used to synchronize JSBML and CellDesigner, we can use a plugin to visualize the synchronization process. So once again, we have our CellDesigner model on the left, and we have our plugin on the right. And these red arrows are signifying that the list of species glyphs, which are in the layout extension, and the list of core species, they've been expanded. So we're able to see when events related to species are taking place. So let's say the user adds a species to the CellDesigner model. We see that immediately the added species was added to the core, and the layout information contained in the species glyph was also added. So that's working how we expected. So in preparation for looking at maybe some reaction data being synchronized, the list of reaction glyphs and the list of reactions were expanded. So let's say the user links to this species and this species together via a reaction. Once again, the reaction glyph information and reaction information in the core was synchronized. But let's see what happens when someone deletes a reaction. And once again, if the JSBML model looks just as how it was before without any additions or any deletions, which is evidence that the synchrony is being maintained entirely between CellDesigner and JSBML. And I know, I just thought of this right now, that all I believe all SBML model elements are being synchronized, not just the ones that you can be visualized like species and reaction. So all of them, even the ones which are invisible and don't actually have a visual representation. So although much of our project goals were accomplished this summer, there still is more work to be done. So probably you noticed that the render attention additions are not yet implemented yet. And the reason for that is a few weeks ago we found that there was actually a bug in JSBML which was preventing us from actually moving forward with the render attention additions. But I actually have very good news. I guess you guys know Nico Rodriguez. 4 hours ago, the bug report was the bug's fixed. And now we can proceed with it. Just right after my presentation, we can start. Secondly, there was some reaction positioning algorithm issues. If you guys are familiar with the process node and SVGN, I believe in the layout extension, it's called the reaction glyph. In the reaction positioning, we had to position the reaction glyph, and there was some guesswork involved. We had to predict where the reaction glyph was. So some reactions weren't being properly transcribed. So here, I forgot, here's the process node. One of my mentors, who's in the CellDesigner community, he was very gracious and very helpful. He heard my concern, and he updated the CellDesigner plugin interface to include coordinate information for the process node. So it'll make the algorithm much more simple because there's no guesswork involved. Yeah, so it's on Sunday, so right after my presentation, I can start on that too. And thirdly, as I kind of mentioned, the synchronization from JSBML to CellDesigner only involves the core elements, no extensions. So we also, we can synchronize the layout, and then once the render, we can synchronize the layout and the render back to CellDesigner. So once this project is completed, we can get all the next steps completed. We hope that this will make the plugin interface between CellDesigner and JSBML very fluid, very easy to work with. It'll provide a way to communicate with the very broad and generic functionalities of JSBML and a very strong visualization function of CellDesigner. And with the improvements we just talked about, it will be a polished addition to the currently powerful JSBML CellDesigner bridge. So at this time, I'd really like to thank my mentors, Dr. Andreas Draeger and Alex Thomas, both of UC San Diego, and my mentor all the way in Tokyo, Japan, in Keio University, Dr. Kira Funahashi. They've helped me so much this summer when I was stuck, when I needed some advice or something like that. They've been very helpful. Finally, last but not least, I want to thank Google for funding this project. And with that, I'd like to thank you guys for all listening to me. And I'd like to open the floor for any questions. Thank you.
No questions. People are very hungry, I guess.
Yes. Time for lunch, guys.
Yeah, great work.
Yes.
Yes. In general, what was your experience working with the CellDesigner plugin interface? Was it?
Let's see. Things have been better lately. A little hard, and I actually have a good anecdote for that. So I did mention this, but Dr. Draeger, he probably about a month in, he helped me develop a GUI error console because the fact was that if there was any one error, nothing would show up. It just simply wouldn't work. So we had no idea what was going on. And that was kind of frustrating. So we have a GUI error console now, which whenever, so you pretty much put all your code in try-catch blocks, and then you use the GUI error console to catch it. So whenever there's a problem, I mean that sped up probably dozens of man hours would have been gone without that GUI error plugin. So thank you.
Yeah, that's true. So
Ibrahim.
CellDesigner basically catches every error that occurs, and then just doesn't
throws it
print
away.
anything.
Yeah.
So then you don't see anything. But if you wrap your code inside try and catch and then print something by yourself, then you can display something. And also the thing is that whenever you want to try your plugin, you need to compile your project and copy it into the plugin folder of CellDesigner and then launch CellDesigner, which is not so very handy, and also for debugging is a bit difficult because you have to print everything, and also log messages don't work, so you need to use system.out to print everything, and then this must be displayed in a graphical display, because also as mentioned, it doesn't print anything on the console. You cannot see.
What IDE do you use then to develop?
Eclipse.
Eclipse.
Yes.
Yeah.
I'm surprised it doesn't let you launch JSBML and then at the host and then let you debug into your plugin.
Maybe this could help. But now, so the idea behind this plugin interface here is actually that once you have implemented something based on JSBML, you only have to implement 2 classes that are in CellDesigner's API. And then you don't have to care about all this, because you can debug your program independent of JSBML. Then